And welcome back. It is the 26th of May, higher plus 5 a day, and let's just jump straight to the first one. Okay, so we have a straightforward textbook style, can you complete the square? So if I remember how to do this, my a term is going to be half of 4, so that's going to be x plus 2. If I expanded this, I'd get x squared plus 4x plus 4. I don't want the 4, so I'm going to take that away, but I do want a 9, so I'm going to add that back in, which gives me my final answer of x plus 2 squared plus 5. First question done. I suspect this question is going to lead off it. So find the coordinates of the turning point. So what makes this equal to 0? Well, that's going to be minus 2. And if it is equal to 0, what is the value that's remaining? Well, it's 5. So my turning point is minus 2, 5. Next question. Shown below is a trapezium ABCD. Describe a single transformation of the trapezium so that only point D is invariant. Right, so important word here. So invariant means it doesn't change under transformation. So I need to think of something whereby basically that doesn't move. And the easiest thing I can do is a rotation. And it says describe A, it doesn't tell me what to do. So any number I want. So rotation 180 degrees, clockwise, anti-clockwise, obviously the same, about point D. And that will do. That's okay. Next question. Actually, sorry, just back on this one. I think D, and I might put in brackets 2, 1, just to be absolutely sure, although I think that should be fine. Next question. Describe a single transformation of the trapezium so that all points on AD are invariant and there are no other invariant points. Okay, think about that one. Right, okay, so if I only want AD to stay the same, well, the points that don't change are the points that are on the mirror line. So therefore, I would have reflection, the name of the transformation, in line, and then I need the equation of the line. So it's got a gradient of 2, goes across 1 and up 2, and it goes through minus 3. So it's in the line 2x minus 3. Now, the invariant points have come up before, and it's one of those things that often people don't say out loud. So invariant doesn't change in a transformation. That is question done. Next question. Calculate CD. So without even looking any further, this was a lot like a cosine rule question, doesn't it? So basically, how am I going to do this? Well, my approach, again, pausing for a second, because I think there's 2 ways you can do this. So I guess, either way, I'm going to have to find the length of a diagonal, and then I'm going to have to find another angle somewhere, aren't I? So let's divide it down this way, and then I can find out length BD. So BD, using the cosine rule, is going to be the square root of 11 squared plus 9 squared minus 2 times 9 times 11. Let's write that slightly neater. 2 times 9 times 11 times cos of the angle in between, which is cos of 160. So calculator out, and that gives me 19.699. So I'm just going to write, because I want my final answer to be correct, so I'm going to write 6992, which is more than enough significant figures, means my final answer should be okay. Now, I've got the length BD, so now I'm going to consider the triangle, this triangle here. And the way I'm going to think about this, so I need an angle, because again, cosine rule to work out CD, I need this angle here. So the way I'm going to do that is I'm going to work out the other half of the angle, which is here, and then take 84, or do 84 minus the angle. So let's use the sine rule. So I'm going to call this theta, so you know what I'm doing. So I'm going to say that sine theta is over 11 is equal to sine of the angle I do know, which is 160, divided by the length I've just worked out, which is 19.6992, which means that theta is equal to sine minus 1 of, all in one go, 11 sine 160 divided by 19.6992. Theta is 11.0102 degrees. I'm going to move over here, so I'm not trying to squeeze it on. So 11.0102 degrees. Right, now, it means I know my theta, which means I can work out that this angle here is going to be 84 minus that, so 84 minus 11.0102 degrees. That's in my calculator already, so just 84 minus answer is going to give me 72.9898. And now back to cosine rule. So therefore CD, and let's do it over here. So therefore CD is going to be equal to the square root of, all in one go, the sides are 19.6992. So 19.6992 squared plus the other side is 16 squared. minus 2 times 16 times 19.6992. Very tedious, but also easy to get it wrong. Times cos of the angle I've just worked out, which is 72.9898. Notice how many decimal places I'm using to get a nice rounded answer. So my answer is 21.4393, etc. So I'm pretty comfortable. The final answer of 21.4 centimeters is what I'm doing. Yes, it is. Centimeters to 3 sig fig. And it doesn't tell me what to do in a question, so 3 sig fig is typically fine. Very good, typical question. Next question. So APC is a straight line. So it tells me that because I'm going to be using angles on a straight line, total 180. Then it says CP equals BP. So let's carefully do this. So CP equals BP, so isosceles triangle. And then it says angle ABP. So ABP is twice, so I'm going to call that 2x, is twice angle CBP, which is this angle here, which is x. And then it says prove, and I want angle BAC, which is this angle here. Now, in an exam, you've got to be very clear that each step you do, you are linked clearly to a reason. So don't just write a list of reasons. It also is really important as well that you also have the right words. So various words are key. So I won't write everything down because it'd be very tedious for you and me to do that. But I will walk you through what to do. So a good idea to actually just quickly work out what you're going to do first, rather than sort of going the wrong way and writing a lot of stuff. So what I'm going to do is I'm going to say, first of all, that this is x. I'm going to argue that angle BCP, so BCP is equal to x. And it's not just isosceles, it's because isosceles triangle and base angles are equal. And it's the base angles bit that matters, not just the word isosceles. And actually don't draw a triangle either, just write the word triangle. Then I'm going to note that BPC, so BPC is equal to 180 minus 2x, because angles in a triangle total 180. So now I know that this angle here is 180 minus 2x, which means that angle BPA is equal to 2x, because angles on a straight, I said I wouldn't write this one, I'm writing it onto a straight line total 180. And then finally, so I've now said that this is 2x, is that what I said? Yeah, that's 2x. And so therefore angle BAP, which is the one that I want, so BAP is equal to 180 minus 4x, because angles in a triangle total 180. Now you've got to be really careful because various words, as I said, like base angles are equal, total 180, angles in a straight line total 180, and angles in a triangle total 180. They're looking for those words. So make sure you've linked the angle that you've found to the reason, and you should be fine. And that is last question done. Quite a difficult day today. I suspect a longer video today, but good one. Not seen the invariant question before. Let me know how that went for you. Do like, subscribe. See you tomorrow.